In this video, we're going to see how we should solve the integral from negative infinity to infinity of cosine x divided by 1 plus x squared dx. Now here I'm going to define, I'm going to use the Feynman technique here, but I'm going to define f of a to be the integral from negative infinity to infinity of cosine ax divided by 1 plus x squared dx. Now if I take the derivative of f of a, it's going to be f prime of a, and the dda here is going to move to here and it's going to become a partial derivative. So if we derive this partial, it's going to be negative x times sine of ax divided by 1 plus x squared dx using the chain rule. Now what I'm going to do, I'm going to multiply and divide both sides by x. So it's going to be x squared sine of ax over x times 1 plus x squared dx. So now what I can do, I can also write this f prime of a as the integral from negative to infinity of 1 plus x squared sine ax minus sine ax divided by x 1 plus x squared dx. Thus the f prime of a, I can separate this integral. It's going to be 1 plus x squared sine ax divided by x 1 plus x squared dx. So I'm going to factor out the minus here. From negative infinity to infinity of sine ax divided by x 1 plus x squared dx. Now these two are going to cancel out, and I'm going to be left with f prime of a equals negative infinity to infinity of sine ax divided by x dx. And from our integrals, we know that sine x over x integral from all over the function is negative pi. So it's going to be negative pi multiplied by negative 1, which is negative pi, plus the integral from negative infinity to infinity of sine of ax over x 1 plus x squared dx, which is f prime of a of mine. Now I'm going to take the derivative of this again. So it's going to be f prime prime of a, which is the integral from negative infinity to infinity of cosine of ax times x over x times 1 plus x squared dx. Now my f prime prime of a again is going to be, if I cancel out these x's, it's going to be cosine of ax over 1 plus x squared dx. Notice that the f prime prime of a is exactly equal to f prime of a, which I defined here to be cosine ax over 1 plus ax squared. Thus I can write this differential equation f prime of a, f prime prime of a minus f of a equal to 0, and the roots of this equation are plus or minus 1. Thus a general solution of f of a to this equation is c1 e to the a plus c2 e to the negative a. So I just have to determine these constant of integrations. If I substitute this thing here, c1 e to the a plus c1, equate it, it's going to be equal to the integral from negative infinity to infinity of cosine of ax over 1 plus x squared dx. And if I let a be 0, I'm going to be getting c1 plus c2, because e to the power of 0 is 1, equal to the integral from negative infinity to infinity of 1 over 1 plus x squared dx. This thing here is the derivative of arctan of x, thus the antiderivative of it is arctan of x, the integral from negative infinity to infinity, and c1 plus c2 is going to be limit as x approaches infinity of arctan x minus limit as x approaches negative infinity of arctan x. The first limit is pi over 2, and the second limit is negative pi over 2. Thus we're going to have pi over 2 plus pi over 2, which is pi. thus c1 plus c2 is pi. Now, in order to determine these constants, actually, I'm going to take f of a, which is c1 e to the a plus c2 e to the negative a. I'm going to take the derivative of it again. It's going to be c1 e to the a minus c2 e to the negative a. And I'm going to equate it to my f prime of a, c1 e to the a minus c2 e to the negative a, which is equal to negative pi plus the integral from negative infinity to infinity of sine of ax over 1 plus x squared dx. If I let a be equal to 0, this is going to go away. Sine of 0 is 0. Thus, I'm going to get to c1 minus c2 equals negative pi. Now I can solve this system of equation. I'm going to say c2 equals pi minus c1. If I substitute it here, pi minus c1, c2 here is c1 minus pi minus c1 equals pi. c1 minus pi plus c1 equals pi. So made a mistake here, I think. c1 because it should be equal to 0. Let me write it here. c1 plus c2 equals to pi, and c1 minus c2 equals negative pi. What I'm gonna do here, this equation is easy to solve. I just got confused a little bit now, but I'm gonna say c2 equals pi minus c1, and c2 negative c2 is gonna be negative pi minus c1. Thus c2 is gonna be c1 plus pi, and c1 is going to be negative pi. Thus c1 plus pi is going to be pi minus c1. Thus c1 should be equal to 0. Now we're talking. Okay, now let's get back to this equation. c1 plus c2 equals pi. So c2 therefore should be equal to pi if c1 equals 0. My general solution therefore is c2 0 e to the c0 times e to the a plus c2, which is pi e to the negative a. My f of a is going to be pi e to the negative a. Now if we go back to here, we defined f of a to be this thing here, and if I find f of 1, I'm going to get the integral from negative infinity to infinity of cosine x over 1 plus x squared dx. Therefore, if I plug in 1 for f, it's going to be pi e to the negative 1, which is pi over e. Thus, we found the result of this integral from negative infinity to infinity of cosine x over 1 plus x squared dx to be equal to pi divided by e, which is a very neat result, and it was a little bit hard to derive, involved solving a couple of differential equations. But thank you for watching this video. If you have any questions, please let me know in the comments, and I will see you next video.